Now, what comes to mind when I say the Internet of Things and the Internet of Behavior? Frankly, if I were to answer, I'd say things that require the Internet and the Internet that is well mannered. But thanks goodness, I'm not the actual expert on this next topic, and we have a whole panel of experts to tell you about it. So let's welcome Guan, the CEO of LGTECH Inc., Chris Phipps, the CMO of Phenometrix, and Oluyemi J. Odeyinka, Senior Solution Architect at Walgreens. These panelists will show us how the Internet of Things and the Internet of Behavior can come together to give a revolutionary transformation to the world as we know it. We also have our moderator, Nadine Cino, the lead AP and CEO and co-inventor of TygaSmart, with us to help keep this session on track. Welcome them all to the stage. Thank you.
So the IoT is really all about connecting sensors that collect data. And then we use that data in the Internet of Behavior to do some predictive analysis. So if I'm a thing, and let's say I'm a pump on an oil pump, and predictively, the Internet of Behavior is going to predict that I'm going to run out of pump power in a month. And so therefore, we've heard a lot about the predictive analytics that can help organizations stay running smoothly and without disruption. But when it comes to people, we're actually less predictable than these sensors. And we're not quite as easy to fix as a pump, nor are we quite as easy to understand as a pump. And therefore, we want to talk a little bit more about the nuances of the Internet of Behavior and relate it back to the Internet of Things. So on either side of me, we have James and we have Chi and Ben, who are really about the Internet of Things. And then Chris and I will talk a little bit more about the Internet of Behavior and how it all ties together. So let's see. James, do you want to start first? Everyone's going to introduce themselves, their specialty. And
hello, my name is James Odeyinka. I'm a solution architect at Walgreens on the cybersecurity. All of this innovation, when it comes from the laboratory into the real world, I'll be the one to test it, make sure that it actually passed the security measure to be able to be used, enterprise-wise. So I have worked on a lot of projects in terms of developing and security. So I can tell you right now about Internet of Things. What are the Internet of Things? Internet of Things are actually you, me, devices that you see around the globe, and the technology that support it. So there's a process, there's a device, and there's me and you. There's no device. If you look at yourself right now, I can tell you right now, the minimum you are carrying is about 2. So that you have a smartwatch, yes, whether you like it or not, is IoT. If you carry your phone, is an IoT. So look at how that goes around. And that actually talks. There's a lot of data that generated. Every time that you walk past through airport, guess what? You are passing through an IoT. It speaks something about you. Every time that you actually put your credit card or your debit card into a machine, you are part of the IoT. They speak on that as well. So if we say that, okay, what is it? Then you will see that we are generating a lot of data. I can actually see you when you walk from A to B, just on that data. So I tell people one thing, we are only 7-point-something billion people on Earth. As of today, we have over 50 billion devices in the world. That is something to tell you that the machines are more than us, but we make the machines work. So I use an adjective that I have been copyrighted over. We are in what we call the explosion of devices around the globe. Yes, I would like to pass that to Chris.
Okay. Well, I thought we maybe, whichever one. Fluid panel. Yeah, no, I said.
I don't know if that's
fluid
on or not. Yes, it's on there. Better? Good. My name is Chris Phipps, project here. I work for a company called Phenometrix. We look at a person's face and decode from that their genetic personality traits with a degree of about 85 to 90+% accuracy. Also take, we can listen to your voice, analyze your text, and determine what your learned personality traits are. All right, so you have genetic and learned. Right now, we have an MVP, so just dealing with companies at this time before launch. So even though I'm in marketing function right now, is more biz dev. So we have right now a handful of companies that are using it for such things as HR, in putting together a large software world project to see how each one can interact with each other. CEOs of companies are using it to learn about their top direct reports from around the world. They can learn that with it in seconds, and that's what we do. This panel here is to talk about the possibilities of knowing a person's personality for artificial intelligence.
Yes, my name is Guan. I'm a CEO of LGTECH. This is my partner, Kenneth Lai. You want to say something?
Yes, my name is Kenneth Lai. I'm the co-founder of LGTECH. I'm excited to be here.
Yeah. Here's our, I just share a little bit about our perspective of the IoT. And then IoT has been around for many years. And only some big companies have some moderate successful to produce the products. But smaller companies tend to be struggle. And why everything has to be based on if you remote control your Internet of Things, you have to rely on the cloud. The cloud have many pinpoints on the cloud. But first of all, they utilize the web services client server model, which is centralized. And then device and device cannot direct communication to each other, right? And then even so, there's an edge that get into the Internet of Things, you still come back to the cloud. So, and second of all, the cloud cost is very huge on the real-time communication, especially. Second of all, they're not security. Remember last year actually, on December, AWS was shut down by hackers. And then so, I mean, hundreds of thousands of users cannot work using their cloud. And second of all, your data is not private. Everything you do on your data, cloud control it. You know, they can see it, no problem. And fifth is like, it's deep learning curve. Cloud is not easy to learn. You need a specialized engineer to do that. And then they need high salary. Don't get me wrong, you know. So, and now my partner have been working on an IoT company for so many companies. Unfortunately, despite his effort and whatever, the companies all failed because of the cloud. You know, so, and then this pain point of cloud, to solve this pain point cloud, we at LGTECH has come out with this decentralized distributed network. We provided this IoT platform with very low and fixed rate, very low. And then, so the things we address here is like, we don't use the client server web services model. Everything is directly communication, in real time actually. And then also we have privacy. As soon as the devices communicate to each other, we back off. We don't control your data. And then next thing is we're very secure. And basically, because there's no client server technology, and then people device can work behind the firewall. And our SDK is very easy to learn, basically.
That's
Something.
fantastic.
Uh,
Yeah.
Well on, G. I would love to answer any question later on.
Yeah, that'd be fantastic. So I'm Nadine Cino, and as I mentioned, I'm an impact inventor. And so the company that we're working in now is called TygaSmart. And TygaSmart is really all about helping, it's an asset tracking system that helps companies and people keep track of the things that they own so they can stop buying what they already have because they can't find it. And as an impact inventor, why do I feel so passionate about reuse and as the new form of environmental behavior that is crying to be adopted? And that is because 31 years ago, let's see, well, everybody on my panel was probably teased before we started, but a lot of people in the audience weren't. But 31 years ago, we started out based on the principle of reuse with a very simple product. It was a reusable plastic box that replaced the use of cardboard boxes specifically for office moving. Think of how small a niche that is in the world of human behavior. 31 years later, I can give you the stats on the value of reuse, which reuse is to the planet as compounded interest is to a banker. Here's what it looks like. After 31 years with one simple box for a niche market, we have eliminated over 3.5 billion pounds of cardboard from landfill. We've not only saved our customers hundreds of millions of dollars in reduced labor costs, we've also saved 55 million trees from senseless destruction. Think about that. Imagine if corporate America could reduce its spend on unnecessary furniture and monitors and all kinds of other computer gadgets that they buy by as little as 1%. What would that look like in terms of planetary resources? So that's what we're up to, and that's why we're considering ourselves to be in the Internet of Behavior, because what we're looking to do is to create new models of behavior using the same tools that everybody here on this panel is using. So if I could sum up what I heard one of the biggest pain points in James's job is security. How do you take this billions and billions of data points per second and keep it secure? I heard from you that the cloud is the biggest pain point in integrating these sensors because we're going through this mediated channel that actually isn't as secure as we'd like it to be. And then I heard from Chris, it's like, we have all these tools from being able to analyze data, but are we losing the heart in all of that? How do we bring that person back into the equation? What are their characteristics? What are their personality profile? And who are we really dealing with? So with that, I'd really like to kick off this discussion. And Ken, if you would like to add something further?
Yes, Nadine, thank you. I would add to this, our technology consider all the pain points that Nadine just discussed. For example, the data security. As you already know, the cloud computing is not safe. It's prone to hacker. So we pioneered this technology where we define is the layer 2.5 that I discussed yesterday, which we created on demand so that the device can connect to the device directly without having to relay that information to the cloud and having someone to watch that data and collect that data or use that data in a harm way. So that technology we pioneer there. And in terms of the massive amount of data and how we handle that, this technology gives you the luxury, the flexibility to store that data at your own premise, at any location you like. So it is considered one of the nodes in our infrastructure that you can create and store that data the way you like. So in terms of privacy, in terms of handle massive amount of data, we have that capability because this technology using what we call the discovery, switch, and connect technology. So each of the computer that we have at the data center can handle 500,000 connection at the same time. And after we handle that connection, we basically discover, connect, and switch the device so that they can connect to each other directly, and we stay out. And based on that model, we can scale out very quickly in terms of handle massive amount of connection at the same time. Thank you.
So what I'd like to do is build a little bit on what Keisha just said in the last panel. She talked about data being predictive, purposeful, and precise. So James, if you could elaborate a little bit more on some of those challenges and how critical it is that the data you're getting is predictive, purposeful, and precise.
Thank you, Nadine. So I'm going to start. I have a very lengthy talk with Chris at the breakfast table today. And I'm able to pick on some of the things that they were doing. And I couldn't believe it at early stage, how accurate they are. If you listen to the last panelist, you will hear somebody saying that I already bought my ticket. And now I'm getting some advert request on something that I already paid for. So that is inaccurate because the person already purchased that, but because it takes time, that's what we call reactive. It's like, you know, the house is already burnt down before your AI call the fire department. What is the point? So having said that, I would like to use something to narrate the behavior and the predictive that we are talking about. So we want high accuracy for it to be able to tell us what is going on. And I'm going to use exactly a spam. I know all of you get, you know, you check your email, you get spam there. Guess what, guys? The old technology that we are using to change the spam, they already know some of the solution that we put in place. So the bad guys, they are architecting a solution to evade some of the control. That's the reason why you are getting a lot of more phishing in your inbox than before. Now, guess what? With AI, guess what? There's something that we call it reinforcement learning. It's going to learn the trick that the bad guy changed to, and it's going to know. Even though there was a lady called Morgan that told me that, these people change. They change their, domain, different emails. Yeah, but guess what? The AI is so smart, it do reverse lookup. And because it has a lot of data that it's using to predict, so it's gonna say, oh yeah, somebody already said spam. Because every action that you take, go back to AI. So I get some emails and I forward it as a spam. It learns that. And when Nadine get that, it's going to say, no, that is a spam. It's not going to go to somebody else. So predictive, being accurate about predictive, particularly about GPS, our location, is very, very important when it comes to the next future, because our future is going to be depending on data a lot. We're already depending on data, but it's going to be more than that. Thank you, Nadine.
Wow, so then security, just even over my own email box, let alone security over my medical records or anything else that might be at a Walgreens pharmacy. I mean, at that very level, we have AI intersecting, being used for both cross purposes, good purposes, as well as malevolent purposes too, right? And that's the rub.
So Nadine just mentioned something right now, but I have to talk about it, even though I cannot speak on behalf of Walgreens. When we are using bot, you guys see that on all of the internet today, on some site that you visit. Guess what, guys? Sometimes we are not asking you for sensitive information, like your date of birth, like your social security number. There's an innovation going on right now that the AI recognize that you are passing your social security to me that I don't need. So I told Nadine that what we are doing is when you click submit, It's not going to go to anybody else. Like Gio was saying, that we want to make sure that your data is being protected. Yes, you click submit, but our AI captured it. And immediately you saw that, it's like, no, this is sensitive. This is your security number. I can send that to somebody else. It's going to encrypt it for you. And that is the power at the edge. Don't forget, you go to the edge before you go out the world. So the edge is going to see that and it's going to arrest that and it's going to change it. It will encrypt it for you so that nobody else can gravitate towards that. Thank you, Nadine. That's a very good one.
Right, exactly. So now, Chief, when you talk about what you've created and you're circumventing the whole cloud, and it's secure from the get-go because you're taking that information from the edge, right? And you're just letting the devices talk to one another. Can you expand a little bit on that?
Sure. Ken, you want to answer that?
Sure. I can augment to James about the data security and also the edge computing. Considering our technology, we can consider one of those nodes as the edge node. So basically, the idea of James to keep the data at the edge, you have that same idea using our technology. So you don't lose that flexibility using our technology. But adding to more on that, our technology offer the concept we call is no web service concept here. Meaning, I'm the fan of preventive medicine than corrective medicine. So basically, if we don't use a web service, there's no way for hacker to be able to see the data on the internet at all. So you don't need to, talking about corrective. But with the AI concept and the IoT behavior concept that James put out, it will add more security to the data that you store or that you manage or you analyze.
Right. I'd love to pass it on to Chris because I think that what you've created, bringing the heart back into the tools that we use to collect data, is a very important component. And then because there are fake people created by AI and so forth, can we talk a little bit about how your technology really focuses or secures the person, the user on the other side of that information that you're providing, that we're talking about a real live human being and not some kind of AI concoction?
Testing, there he goes. Actually, not on me, right? It's way off in the future of Web3 when each person has their own personal data stored in a solid tech blockchain and crypto, may have done all that. That's on down the road. So when that comes about, then part of our personal ID could be, should be, not just your face, okay? Maybe your bank information, all that, social security number, but your personality. So that way, when you were to, okay, and that's one way to further authenticate yourself. Now we have two-factor authentication. We have personal pod. That's not working. That is, that'll be like level of authentication that you could, in theory, use. All right. So that's one way to avoid encryption. It's right there. It's not working still. What we are doing right now, though, I know, I think they answered the question, right, on that?
Yeah.
Okay,
to the best.
on how to authenticate somebody a little bit better. What we're doing in the short term is we'll be working with, of course, selling more products. So not us, but our customers use it to sell more product. Well, they can go to social media because that's one of the biggest sources of data about yourself right now, social media. In addition to search and location. Well, social media, you give up so much information about yourself. We can use that along with your face, or our customer can use that to be able to target ads precisely to you. Is your personality impulsive? Are you the type that likes to look a lot of stuff? Are you conversational? Are you influenced by others? Are you not influenced by others? Do you want data? Do you want social information? All that can be used to target a message to get you to buy quickly and or to point you down the path of clicking to buy quickly and efficiently. So that's one of the first applications I've used. Longer term, I see it where artificial intelligence is creating now androids. You may have seen on TV, The Late Show and all. These humanoid looking androids that'll be interfacing with you or could be in the future interfacing with you at an airport kiosk, at a hotel. Well, that's great. You can walk them and say, Miss May, I need to go to a restaurant. Can you recommend Italian? It'll give you some answer about someplace down the street very well, right? What about if it could see your face, and as soon as you ask a question, it would know your personality, your basic personality based on your face and how you ask the question, tone of your voice, other things. It can infer a lot about your personality and then maybe your mood. Now it could answer you like a real person. When a person walks up to you, you know in the first 5 to 10 seconds something about them. It's our gut feel. Science has shown that that's pretty much right. Not always, but pretty much. What about if an Android could do the same thing? Now it's going to interface with you in the way that you like to be interfaced with. That's ultimately is the ultimate goal of AI. AI without that, it's just artificial. It still stays artificial. It has to be able to understand people, not just through repetitive online history, days or weeks of doing things, but that instant recognition when you walk up and say, hi, my name's Chris. I need to go to an Italian restaurant. Oh, they know that, oh, he likes to go around and look at a bunch of things. He likes to talk. He doesn't like to talk, all that. So that's the end goal. The interim goal is digital marketing folks are going to use our product to sell you things better. So hopefully it's used in a good way, not a bad way. So I can't control that, but we can recommend that. Yeah.
You know, Chris, you remind me when you just said about that Android, right? That's going to come at you and they're going to know if you're the kind of person who's a kind of a data person who just wants answers or somebody who's a little more conversational, right? And they'll respond accordingly. I don't know how many people here have read the 5 love languages, but it really reminds me of the 5 love languages are really speaking to us as the reader of the book, of the people that are in our lives and the different ways in which they want us to tell them how to communicate how we love them. So not everybody is huggy, squeezy, cuddly, right? And so this is kind of similar in that regard. I mean, we're not getting to that point of a love language, but we're certainly getting to that point of a communication protocol that really is mirroring what the other person wants, right? Mirroring, yeah, yeah, much more human. Exactly. So talking back to Keisha's point about purposeful, right? What we're looking to do at TygaSmart is to use this data purposefully so that we're really encouraging reuse and reducing the unnecessary consumption of planetary resources. And so how we do this for corporations is pretty straightforward and simple. Most of the products that they buy, whether it's furniture, or fixtures, or equipment, whatever it is, they all pretty much have some kind of a stated life cycle. And so what we're looking to do is kind of help discourage corporations from thinking of furniture as fast fashion. Because oftentimes these furniture assets, which take a lot of planetary resources to produce, are oftentimes discarded within a 3-year period or a 5-year period, many times before they're even fully depreciated. Reasons for that most recently are, well, we are no longer doing the classic office configuration. Now we're creating for hybrid. So all the furniture that we use for the classic office is getting ditched somehow or another. We're buying new and we're creating a new communications tool with our furniture to our people. It's interesting though, when you do the studies and you take a look at what is the common denominator that companies are measured by in terms of performance to energy consumption. And that common denominator happens to be carbon, a ton of carbon. And so that's really now the basis that's forming the ESGs, which stands for environmental, social governance. And that's really been promoted by the UN. And now it's being adopted by Wall Street to understand when a corporation behaves in an environmentally sound manner, they actually end up reducing a good number of risks due to climate impacts and labor impacts and so forth. It's all measured in carbon because it's all about our energy consumption. So interestingly enough, and not to digress too far away, in scope 3, all of the furniture, fixtures, and so forth are also measured in carbon tons. And here's what we found out. And I'm just going to use this as a stat to make it simple. If I am a corporation, I buy a chair. That costs 100 carbon units to purchase that chair. When I throw it away, I throw away only 10 carbon units, but I cause another 100 carbon units to be consumed by throwing that chair away. What is really interesting about these stats is when you get to electronic equipment, instead of a 10-to-1 ratio of I'm consuming 10 times more carbon to replace the chair I just threw out, what happens is I'm using 25 times more carbon to replace the monitor I just threw out. Now, how many people look at monitors as disposable? Because they're cheap, a couple of $100. But what it causes on a supply chain is ginormous. And so what we're doing at TygaSmart is we're calculating the number of times that they avoid purchasing a new chair or a new monitor and help them accumulate carbon offsets that they can use for other aspects of their company where they have a carbon deficit. So they can apply the offset to the deficit. And when they do their ESG reporting, Wall Street looks at them as a very sound, environmentally principled company who's doing the right thing every which way that they can. And that is why we're so excited about the ability to tie the entire ecosystem and include the planet as one of the stakeholders in the equation of behavior, the Internet of Behavior. And we're using that stat in order to see how we can help to shift the behavior so that we end up doing things for the planet that are worthwhile. So with that, I'd like to say that.
Well, then you'll like us because we can identify 85 personality traits in about 2 seconds. So I think
Exactly.
we're pretty low
That's-
carbon, I think. We're just,
Well, you know, it's so
are
funny.
degraded in like a tenth of the carbon. We're down in 1/100th of the carbon. That's good.
I think that's brilliant. I really think that's brilliant. And you know why? I mean, when you look at it the way the universe just puts people together, it's a happy collision that we're all here on the same panel because we're all looking at the same issue from a very, very different point of view. So I'd love to open up the floor. Does anyone have some last comments they want to make? Because I think it's important for us to get feedback from our attendees.
You wanna talk about the cost of
Oh, sure. So at the end of the day, we look at the IoT business and we also look at the cost of making the IoT products for the ecosystem or for the Internet of Things. And we have to consider the cost of doing this. And if you look at the cloud computing, the cost will be huge. And also we want to look at the challenges of having a robust, reliable IoT product that the consumer would like and is satisfied with that. So the technology that we come up with will satisfy those consideration.
Yeah.
I have a question about your, you have some algorithm that behind this Internet of Things, I mean, Internet of the Behaviors.
Yes.
So it is possible to eliminate those unconscious bias
Well,
in your algorithm, yeah.
see, fortunately for us, we're simply counting utilization. So it's very objective data to begin with. There's nothing subjective about it. I think what Chris is working on it's actually quite objective as well when you think about it, right? Yeah. So I think that as far as the unconscious bias in some of the algorithms that we use across the board here, I'm going to kind of step out and say that for the most part, it's objective data.
So, Chiu, I'm going to answer that because there's a twist to what you just asked, Nadine. So if you look at it, if Nadine's team started predicting that if you buy from this particular manufacturer, the life cycle that they are posting is 10 years. But based on our algorithm, we find out that the life cycle from this manufacturer are only 2 years. If they started doing that analytics, Chiu, what you said, they can inject unconscious bias, both conscious and unconscious, into it. Because guess what? Some people can pay them to elevate them of their life cycle. Yeah, that is the real effect right there. Meanwhile, I know that Nadine, you want us to allow people to ask some questions if they do. But before we go into that, I want to remind everybody here, if you are using data science or your company is using AI or using machine learning to do anything, so there is a program going on right now that people have understand the bias. So what they are doing right now is they are going to replace your training model with a virus. So we're going to attack the training model that you already published. They're going to attack it with a virus. What happens is that if it is predicting at 85% that you are telling your customer, the virus is going to make it less predictive. So the accuracy and the precision of your prediction is going to go way down. And when it go way down, it's going to affect sales. So we tell people, please, if your training model is there for more than 6 months, you need to go back and start checking with real data. Just test, perform the test again to make sure that they have not replaced your training model with a virus. This is something new that is going on in cyber world. The government are also doing their own training, but I just want you to know about what is going on. You will be missing some sales if you depend on that.
That's an eye opener. That's a real eye opener. Well, okay, I think we want to invite, Chris, anything to say before we invite everybody up? Okay, no? So questions. We have about 7 minutes left. Helen, we knew we could count on you. But is there, and Helen, if there's someone after you who wants to ask questions, please give them some space too.
I have a simple question, but it may need everyone who use after the test. Given that European Union has a need to build a information system for cargo and travel tracking and monitoring, what will you suggest from IoT standpoint, from management, from policy, from the regulation? What needs to be changed? What needs to be included? What needs to be considered? What needs to be removed?
Chris, you want to take a step?
Sorry, I didn't quite understand.
Okay. So she's saying that if we want to build an IoT for like a cargo company, yes, she's now saying that what are the governance and what are the things that we would like to put inside them to make them more functional and more acceptable by people.
Not just cargo and travel.
Cargo and travel.
Oh,
And
cargo.
human.
Oh, yeah.
Yes.
Well,
Cargo
all right.
company.
Well, seeing I was at the wireless
China,
sensor
can we just
networks.
take one.
I can answer that question.
Policy And cargo is pretty standard ship.
I'll do cargo. I'll do cargo. I was involved in a startup back in 2004 where we called it wireless sensor networks before IoT. It ramped up and it crashed, and now it's come back as IoT. 28 years ago. Wow. So we were all about intelligence at the edge at the time because it was too expensive to bring all the data back and analyze it. Now, then all the data was cheap to come back. Now it's too expensive to process it. Now it's gone back to intelligence at the edge. So I think the important thing to do at the edge is decide, try to monitoring what is important to send back to the cloud or send back to a server or to send on to other points of the network like you're trying to do. Decide that first. Decide exactly what data is important to get. The data you get, you have to filter it. You have to sanitize it. You'll get a lot of bad data. So you got to filter it to what you need. You got to clean it up. You'll get data that's all over the place, right? So those are important things there. And finally, you have to decide what magnitude is their problem that you want to send alarms. A lot of things that there's other approach too, that they did this with buildings and other things. They would establish a baseline. They would collect data for weeks and weeks and months. And if everything was going normal, there's no failures in the building, no short circuits, nothing was on too long, nothing was drawing too much power, the AC was working right. Once they got all that figured out, then they decided that's our baseline. Now we look for abnormalities. Now we look for exceptions to the baseline. When something spikes up, too much power here, too much cooling here, the door's left open here too long. It's doors are open after people should be coming in and out, like the school where it should be locked down. It's open too long. You look for abnormalities. So it's complex. You decide what you want to look for. You filter only for that. You keep monitoring for a baseline for abnormalities or for unknown unknowns, and then you sanitize the data. And in the end, you have to have people look at it. You have to have people look at it all the time saying, look at it. Why is that happening? And then you build up a way of monitoring what's going on and reporting it. Somebody else wanted to do something where they used our chip and our little board. They would put it on cargo. So you note how I came around to the beginning. That's good. So for cargo, that's called closing it up, right? So for cargo, they wanted to put it on every railroad car. They would monitor shock, like let's say windshields, too much shock and vibration. They would say, oh, the windshield's damaged, send a report back. Ford, we need another order from the glass factory. Otherwise, it could take some week to get there. You'll have a shut on your line. So they can start to order immediately of new windshield or glass. They would also track trucking, how far car would go back and forth. And that they would monitor temperature for produce and all that. All those things can be monitored, but they'd only send it back if there was an alarm. In addition, on the device itself, it could collect baseline information they could look at when it got back to the depot, to the rail yard. So that's just one example. There's so many things you need to look at. So
Yeah.
I don't know if that
That's
answers the
really
question. or
great.
not.
Yeah, I think we
I-
have somebody
I-
who wants to ask a question behind you.
I can answer that question for you. That's a very good question. What we call is our technology, what we call is a fleet management. And I will offer you a solution for that. That's precisely what we do here. At the hardware level, you will create the IoT products that will attach to each of the fleet. And let's say for the cargo, you have a container, you can attach the sensor to each of the items in the container. And the sensor will send out that data to the gateway somewhere. And that gateway will send that data to what we call as the control center. And each of those data, each of those devices will be considered as a node in our network here. And we have the control system to manage all the fleet around the world and any IoT device inside the container for you.
Very good. The budget for this European Union cargo and travel system is $2 trillion. 2 trillion. So think about the budget and think about the areas to be considered. Where do you propose to put the Internet of Things? What type of Internet of Things should you buy? And where to install them? How to monitor them? Who will manage that?
That's exactly the architecture, the solution that we have. And the cost of implement that solution for us will be very low.
Thank you. Thank you so much, Helen. We have one more question.
Is there one or two?
Or is there more than? Do we have?
Maybe some of, I guess, I think that I feel exciting, all this stuff but I think there's still areas, to ask you, but what is the age group of the highest adopters? Who is more willing to try it?
I'm sorry, the age group of the what?
Of the IoT, who is more
Early
able
adopter.
to use it? And the second question is, how do you democratize IoT so that those that are not currently using it, I think you have to maybe privacy, even just, how do you get them?
So that is very interesting. And I'm going to use something that you can see very quickly. Healthcare is the leading user of IoT today. And I know many people might not know this. You see the defibrillator that people use for the heart transplant that they do is an IoT. So now people have taken it a little bit higher. We now have that they are sitting down and these things that we actually allow them to their own app. And then we use IoT to monitor them. What we do with that is, we can monitor your fall. You can monitor when you get up. We can elderly people. And that is the power of IoT with healthcare. There are so many people right now that when we, to cut the cost, because everything is about cost. So somebody just got out of surgery and they are, because if they stay in the hospital, you know that the bill is astronomical. What we did with that is we send you home, we put a lot of IoT devices on you, on the machine, to tell us how you are doing. The doctor knows when something is gonna go wrong, and we're gonna come home, or we're gonna send a nurse to come and visit you and correct whatever issue. If you need to be rushed back to the hospital, that has been arranged. That is one of the huge, in that area. And guess what? Energy is using that. You will not believe how much IoT that are in airplane that we
Airplane, it's huge. So when they land, there's terabytes of data that are uploaded.
Right.
Basically for Honeywell is inside of many things. It's not on a sensors. So I know that there's specific medical device providers that was basically create a sensor for detecting like if the man is wet and you have a similar patient.
Yes, that's not.
So they don't get tested. This is something technology provides. In some cases, the medical use is the responsible use of it because it's for the best interest of the person. How do you justify like a consumer having something embedded in privacy that's listening in to every single thing you're doing? That's what I think most people are scared about. And like, for example, going to Amazon Marketplace, where every single camera looking at you, you don't know what they're doing. Because I think it's the black box concept of like, don't worry about it, we'll take care of security. You don't have to. But that's what I think is scary.
That's exactly our technology.
That exactly our technology is. We address that issue of the privacy as you pose the question for the medical device. We can store that information at the premise or at the closest location where you want to use that data for your patient, and that they will be private only to you, and nobody can touch that data. And consider that as one of the node of our network, and that node is very secure.
Data on person's heart. It was very, very advanced and it just failed because it got through all the clinical trials. But anyway, and it could do a complete workup and diagnostic on your heart. So it sent to the doctor and they could know when they need to retitrate your heart medicine. It could be sent to a lot of other people, hospitals know what's going on. And what was interesting about it is the big play I saw in it was to be able to sell the data to the pharma companies. They wanted that badly because they could see this patient has all these conditions. They're using our medicine. Then all their variables are going on with their heart and things change. Why did it change? Well, all you have to do is just anonymize it, where you would strip out the name, you keep maybe their zip code, their demographic in there, and you can strip it out, and that complies with HIPAA. So, and my wife's a doctor, and I help out in her office, so HIPAA is a big, big bugaboo. But if you strip out some personal things and put other identifiers like 1, 2, 3, 4, 5 number patient, you can sell it, and that's fine. But you got to be able to strip out the personal information.
And so speaking to the original point, when I talked about in the IoT, when you're monitoring things, and I used a pump on an oil pipe as an example, we're talking about a pump in your heart. So you see how it's all connected, all this data really, really comes together. And it's how we're going to communicate our health as humans, our health as a planet, and our health as businesses in the future.
Web 3.0, Web 3. That is the future. We just don't know what vulnerability is going to come out of it. I can tell you that. Web 3, Web 3.0 is the future that all of us are relying on, and we don't know what vulnerability.
Thank you, guys.
Thank you.